Hi everyone, welcome to the Fedora CoreOS talk. I am Sinny and I'm working in Fedora CoreOS and I am contributing to Fedora from like maybe 4 years or something like that. And Jakub.
My name is Jakub. I'm software engineer in Fedora multi-arch team at Red Hat. I'm contributing to Fedora since I started at Red Hat like 5 years ago. And you will see how my work fits into the Fedora CoreOS.
Okay. Can you tell me how many of you have already used or know about Fedora CoreOS, some context? Can you raise your hand if you know about Fedora CoreOS? Okay. Okay, then yeah, I think we'll give some introduction and we'll proceed with the talk. So here's the agenda for today's talk. And yeah, let's get started. So what is Fedora CoreOS? It's an operating system, and it automatically updates, and it's a minimal operating system for running containerized applications. And its aim is to run the container workloads securely and at scale. You can run the operating system in the cluster, or it's also works well in the standalone. So yeah, it depends upon what kind of use case you want to use it. Also, it's a new Fedora edition, so it has all the underlying things is RPM. So, and it coming from the Fedora RPM, which you have all signed, and everything is from the trusted place. We are not using anything additionally here. Also, it is upstream for RHEL CoreOS, but with broader scope, because RHEL CoreOS is mostly right now in the OpenShift, but Fedora CoreOS can be run standalone or with other use cases. So a little bit of history about the Fedora CoreOS. So we have Fedora Atomic Host, which is currently getting released now as well with 2 weeks of release. And there is Container Linux from CoreOS. This came from, after the acquisition, these two were together here, and we were like, we have two awesome distribution, which is both have common goal, running containers. And we really want to have something even better, like it's better to use both and get something new, which has better benefits and all the awesomeness from both of them. So here we are with the Fedora CoreOS, a new addition within Fedora. So it's like we are trying to get this from like last year, this Fedora CoreOS, and it's taking time because we are maintaining Fedora Atomic Host, and as well as we are maintaining Container Linux. We have users for both, and we want to maintain them, and we want to develop something new, including both. So we have a lot of design decision to do what we want and what is best for the new operating system. So yeah, we are here with the new operating system with the awesomeness of both of them. Features. So if you already know about RPM OS3 or OS3, it also uses the same technology in underlying. It has OS3 and RPM OS3 on top of it. So we have immutable host, which means the /usr is read-only file system. So like if you have used Silverblue or Fedora Atomic Host, you already know that the /usr is read-only mounted. So you can't change there anything, which keeps the host immutable. Also, it uses RPM OS3, which gives the features of automatic update and rollback. We'll get to know more about the updates mechanism later on. But here, we have atomic update, which means that the entire operating system receives the update together in one transaction. So if you know about Git, it follows the same mechanism, similar kind of functionality, like everything in your entire OS is kind of kind of composed together, and it forms a single commit. So everything can be tracked here, and if whenever a new update happens, it's like a single transaction update. And if something goes wrong, we have a very nice feature rollback, which you can use to go back to the previous working system. And everything is tracked, so it's really easy. And Fedora CoreOS have Ignition. So Ignition uses Ignition config. So during the first boot, Ignition runs the Ignition config, and it configures the system, basic things like user creation, the system partitioning, or anything you want to do. Or if you want to add something, system unit, you can add it in the Ignition config, and system will take care of during the first boot. So what happens is you either get a working system when you use Ignition during the provisioning. So whenever your system runs, your Ignition runs successfully, then you have a working system. Otherwise, your system is not running. So yeah, it doesn't leave you in between intermediate state, like it's not working half of the things. So unless everything is working fine, it won't give you a working system. So that Ignition really helps a lot here. And it only runs on the first boot. Okay. And it provides you immutable infrastructure. So what we mean here is, in Fedora CoreOS, what we want is, you don't change anything here on the host. Let us manage everything to update, and you only have to run your application there on the host inside container. So everything will be running smoothly, and we'll take care of the host, updating it with all the security fixes, etc. Suppose you want to add something change something in the configuration in any of the etc file, because it's the OS3-based system, etc, you can change things. And /var is also like writable. So if you want change something, please don't do it here. The recommended way is add something into the config and provision a new system with the updated config and discard the old one. That's how you maintain the infrastructure immutable. Like, you're not changing anything. It's the same thing with whatever you have provisioned in the beginning. Also, it provides you rolling release. Rolling release is like very interesting. It came from, let's say, Container Linux. They have different channels called alpha, beta, and stable. Here we are using rolling release thing. We have different streams. So like, if you are there is a single ref, which we call in OS3 way, or if you are using Git, you call it branch. So yeah, you have a single branch, and you will continue receiving the update there for the entire lifetime of that particular system. We'll get to know more in detail in future slides. Also, Fedora CoreOS has no Python on the host. We were able to get it after some effort and discussion on the community channel, how we want to get all the benefits and still remove Python, because Python is in a lot of things. So we really worked with maintainers, and they were really friendly, and we were able to do sub-packaging and get whatever we wanted in the host and without Python, and whatever was Python there, it was moved to either another sub-package, or we figure out we'll remove that from the base, and we'll try to get that functionality from the container. So yeah, we have no Python on the host. Also, since it's a minimal operating system and it gives you containerized workflow, we have all the container tools available in the host, like Podman and Moby, which gives you Docker. So they are pre-installed, so you can try whatever you want. But yeah, Podman is the preferred way, I would say. Okay, so release stream. Let's talk in detail what the release streams is. This is a new thing, I'd say, at least in the Fedora side, because I haven't seen these in Fedora so far. So we have multiple streams here in Fedora CoreOS. So we have categorized it into three. First is production. So there are three refs in production. Three refs, you say, three streams, you say, or three branches, whatever you can say. Like if you have used atomic host or Silverblue, you would have seen there is a ref when you do RPM OS3 status. There is a thing called x86/64/30 and something like that, which keeps changing every time you update to a new version. Like if it's a 31 base, then the ref will change, and you will have to rebase your system to the newer ref if you want to update your system based on the latest release. So here we have these only streams, and it will receive the update for the entire lifetime. So one is testing. So what testing tracks is the current Fedora release. For example, we have currently Fedora 30, so there will be Fedora 30 content and the body updates which we have in the Fedora 30 and any additional fixes. Like if we're not able to get something in the current release and we want to get it as soon as possible, then we try to get that additional fixes in the testing. And then stable branch. So stable is basically promotion of testing, because we don't want to add any regression there. So testing is already like people are trying out from few days or something like that. So we know that these are working fine. So it's like it gives you extra stability, and the testing after a few days of baking, it goes to the stable release with any additional fixes. If any end moment fixes comes out, then it will definitely go to the stable stream. And then there's a next stream. So next is for tracking the new upcoming features. So Fedora has right now Fedora 31 upcoming. So next should track Fedora 31 after the body, the branching happens and body updates is enabled. Otherwise, it's of not much use because we don't have any next coming, so it will be mostly testing, you can say. And yeah, these are the three streams which is recommended to run in production, and the recommended way is to have some of your nodes on testing, some of the nodes on next, and majority on the stable, because yeah, that's the stable. And why testing? Because you can get and see the regression coming in your system, if any, in advance, and you can notify us. And yeah, you don't want your entire nodes or cluster getting down. So that's the recommended way. Have some on testing, some on next, and remaining on the stable release. And the source of the packages coming here are from CoreOS pool repo. So what we have here is whatever packages are coming in the Fedora CoreOS, we want to keep track of everything. So we have a new tags created by Relange, which is called CoreOS pool, and all those packages goes there, and we have a big giant repo there, and everything comes from there. So the reason of doing this is we want to make sure that we can rebuild anything we want in future. Suppose something was done 2 days back, and if there is a new body updates, the package will get updated, and you will never be able to get the same compose or anything using the current version. So what we have here is in CoreOS pool, we have a log file mechanism which will help you to, which we keep track of in which version, which all packages with NVR has been there. So that's how you can reproduce your build, and it helps in testing or any other things. And these are the development streams, testing devel and next devel. So testing devel is the nightly snapshot of current Fedora release, which will be 30, and the body updates. And periodically, it gets snapshotted to the testing stream. So the testing, what we have in the testing, production testing stream, that comes from the testing devel. And next devel is for tracking the next thing. So whatever comes in next, it will get snapshotted from the next devel. And it contains the upcoming Fedora release, which will be Fedora 31 in this case. And this is not recommended for production use. This is mainly for testing or anything, developer testing or something if we want, or mostly things will be running in the CI, so we catch any regression in advance and before getting anything into the testing. Also, the source of the packages are in CoreOS pool here. And these are few refs which we call branches or streams we call as mechanical streams. These are branched, body updates, body update testing, and rawhide. We try to keep the name similar to what we have in Fedora so that people don't get confused. So branched is then the next upcoming Fedora, which is like once it gets branched, like after some time when stable version release, we branch from rawhide. So that time the branched will be in use, and that will contain the nightly snapshot of the packages which are in the branched. And body updates is like nightly snapshot of current Fedora release, body updates included, and yeah, similarly body update testings are which includes current release, body updates, and body update testing. So the reason is to have these refs so that we keep at least CI for everything checks. So we can easily go back and see when something goes wrong, and if we want to test something new upcoming in Fedora, we can quickly have VM or instance launched from these and check it out there rather than realizing later and getting sad that, okay, these things came into the production or testing and people are going crazy because things are broken, and we want to keep everything in rolling release, so we really want the system to be stable. So yeah, these all the things are hopefully like extra precaution taking and everything to keep things stable here. And these are also not for production use. So for production, you only use the refs which are mentioned in the production section, which is testing, stable, and next, and majority on the stable. Also, the source packages are here directly from the Fedora repos. So whatever we have in the Fedora repos, the current one is just using directly that, nothing else. Okay, so now we talked some components which we use in Fedora CoreOS. Some of them are already available in the Fedora CoreOS host itself, and some are like we use to develop the Fedora CoreOS itself. So for example, CoreOS Assembler, this is the building tool which is responsible for creating all kinds of image artifacts which we have in Fedora CoreOS. For example, ISO, QCOW2, or OpenStack image, or AWS image, anything we want to develop, everything is coming from CoreOS Assembler. There is a single tool which is really easy to develop also, because you can quickly and easily run in your system. It's really very easy. Just you can go to the GitHub page and follow the documentation. It's really very easy. And RPM-OS tree, yeah, is the heart. It's like it used to compose the OS tree repo for the Fedora CoreOS. Also, it's responsible for updating the system, rollbacking, everything is done through the RPM-OS tree. And then Ignition, which is for initial configuration of the system during the first boot. So it runs during the initial RMFS, whenever the system first boot, and once the initial config run, everything gets updated, and then it switches to the real root system. And we have Mental. Mental is for running tests. Like it has a subcomponent called Cola, which runs which launches in the AWS or other stuff images, and it tests really quickly things. And it also do the releases stuff, uploading to the different cloud providers. That's really pretty cool application as well. And Zincati. Zincati is a really new tool. It has been developed recently for coordinating the automatic updating. So it is in the client, which listens to the Cincinnati, another tool, and if it sees there is a new update, it says to RPM-OS tree to update the system and then reboot it. And I think if system doesn't boot fine, then it will automatically roll back to the previous version. And there is an FCCT, so this is called Fedora CoreOS config transpiler. This is also a new I'd say in Fedora. It's from Container Linux. They were using like we don't directly write ignition config because that is in JSON. We provide something a bit more human readable format called YAML. So we write YAML config, and FCCT, what it does is it converts it into ignition config, and on top of it, it also checks whether your config is right or not. If the config doesn't look good, then it will throw you error, and it will fix. Then you fix it, and then you get a new config written, and then convert it to ignition config. So that's because it's really important, because ignition config runs only once, and it helps, it provisions the system, so that needs to be the correct format. So FCCT really helps a bit, so it's recommended don't write ignition config yourself, use FCCT tool, and where you write Fedora CoreOS config. Okay, so since we are talking, you can see how Fedora CoreOS config look. So yeah, it's a YAML syntax where right now it's 1.0.0, so that's the version defined, and these are the syntax. Like here is the name of the user which we are creating, and the password hash. This is a salt password which we create whatever you want to give, and then SSH keys which you want to add. Which all groups. This is a simple FCC config file. There are a lot more things you can add there, like systemd unit and file system configuration, something like that, so that you can check the whole things on the ignition or the FCC documentation page. And to run this tool, you simply do the FCCT this command. You run it, and it converts you into the ignition config. The last command written there. Okay, and there is a really very interesting, which was very recently we were able to do that, and it's really important, the auto update thing. So really, I really enjoyed it because it was done recently by Luca. He's sitting here, and what it does is it auto update your system and in a rollout way. So what happens, you can, if you see this file, it says updates, and there are some barriers and dead ends. So what happens that since it's a rolling release and automatic updating system, it happens that a user can be on any of the previous version nodes or anything. So suppose it can happen that sometimes your system is on updated system, and due to some reason that particular version was not good or something like that, then we would like, or any other issue. So we want users to not update from that system to another. That's kind of a bad kind of version. So that we call dead end, because it ends there. So we keep track of those kind of version here. For example, recently when we did the release of Fedora CoreOS, this particular version, which was 30.2019 7.16.1, there were some issues related to RPM OS3, and because of which we're not able to auto-update. So we kept it in the dead end section here. And this is the most interesting thing, rollout. So what happens is there is a rollout period defined, in which all the nodes which is available in the internet, they will receive the updates. So we define here a version number, so which is the latest version which we are going to release, so that the system should be updated to that particular version. And this is start epoch, so the time at which the rollout will start, and there's start value, so this is the percentage, which is 0 in the beginning, and the duration, which is 120 in minutes. So what happens is in 2 hours, all the system will be updated to the latest version automatically using Zincati or RPMOS tree, which is on their host. So the update will start from 0.0 and the percentage keeps increasing as the time goes on, and at the end of 2 hours from the start time, which is mentioned in the start epoch, all the system will automatically update it to the latest one. And suppose something goes wrong, then we also have feature to pause the rollout and do the fixes, and we can roll out a new release. That's really interesting here. Okay, now I will hand it to Jakub.
So currently, you can get CoreOS only for 64-bit Intel. It targets bare metal environments, so your server and other boxes. It targets like the mainstream virtualization environments, QEMU, VMware, OpenStack, and VirtualBox. You can also run CoreOS on like the mainstream cloud providers like AWS, Azure, DigitalOcean, on Google and the packet. Here comes my work. Currently, it's just the 64-bit Intel, but I'm looking into way, with help of others in CoreOS, to get Fedora or other 64-bit Fedora architectures, like 64-bit ARM, PowerPC, Little Endian, and 64-bit mainframe. Currently, I'm looking in direction of the bare metal, OpenStack, and QEMU, basically virtualization and the bare boxes. I haven't looked into direction of the cloud providers. I think it's really open questions. If there are some that would be interested in that. Current state of CoreOS for the multi-arch, it's actually building and running, but just locally. We do not have infrastructure that currently the Intel version has, and as the whole CoreOS is built, or Fedora CoreOS is built on top of Fedora, we could leverage a lot of work that CoreOS folks did and that was done in Fedora. So it was fairly straightforward to fix the individual issues, and really big thanks to the community and CoreOS and Fedora CoreOS folks. So currently the next big goal is to set up build pipeline similar to the Intel one. We'll probably need OSBS and the rest of the bits as an OpenShift cluster that's used in build of CoreOS, Fedora CoreOS. So I will give.
Okay, so we talked a lot. So let's see where we are currently. So we had the preview release on 16th of July, which we announced. And so in this release, what are things are really already available. So yeah, we have x86-64 images building, and we are currently having testing stream, and you can download the artifacts available from getfedora.org /en/CoreOS/download. So all the available images are there, and once every time we do update, things will be updated on the website, and the new artifacts will be automatically be available there in the website. So yeah, do try it from there. Also, in this release, we have the bare metal support available, so you can install it on your bare metal in the PXE or using directly ISO. And the QEMU also works for us, and OpenStack images are also there, VMware images are also there. So you can try on these platforms from the preview release. And we have also in the cloud provider, AWS, it's available in the AWS, the AMI is available, so you can launch something there and try quickly. Also, the no Python on host is there, so we were able to remove the Python dependency from the host. And yeah, the automatic update is also in effect. So if you have like latest version of Fedora CoreOS preview release installed on your system, so whenever we do a next release, it will automatically update your system, reboot it, and you will have the latest one. So these all things are already working and in place. Yeah, so let's see some demo so that it's not like I'm just talking here. Okay, so what I will do, I will do a quick demo with the QCOW2 image because it's easy to launch. And okay, so let's see first. As we talked, we don't write ignition config directly. We use Fedora CoreOS config, which is in YAML format, and we write that, and we let FCCT tool to generate the ignition config from there. So I have this FCC config available. Okay, so you can see it's just a simple one with the password and the username. This is the salt password. You write it here, and the SSH key, and I added it in the wheel group so that I have the sudo access. Now I have the binary of FCCT tool for the Linux downloaded here. So I will use that to convert it into ignition config. Okay. So now we see what we have. Yeah, so it basically generates a lot of things since we haven't defined these stuff. So it's blank for now. The version is 3.0 ignition. Here we can see the latest one is the 3.0. The password, the section which we added is here. Groups, users, name, password hash, SSH key, and storage and systemd units. We haven't defined it, so it's blank for now, but you can definitely add your own systemd unit and other stuff, whatever you want to, however you want to configure your system. So let's run QEMU command. So this is the simple QEMU command. We are giving 2 gigs of RAM and CPU, and this is the QCOW image. This is the latest image which we have from the 1st of August. And yeah, the ignition config, you provide it in this way in the QEMU. So it's booting. It will be very quick. Yeah. So the username was core and the password was test. And it's right now everything is getting printed out here. So it's fine. Let's see. The first command which we usually run is RPM status so that we see where we are. Okay, so here you can see we were talking about a lot of streams. So this is what it exactly looks. This is the stream name here, Fedora /x8664 CoreOS /testing. So this is the exact name of the ref which we use. And if you see, it's testing, and we are not specifying any Fedora version here because it's going to be a rolling release, and it will be always the same testing, which will receive updates every time. So in case if you have used Atomic Host or Silverblue, you see that whenever a new release happens based on like Fedora 30, you do RPM OS2 rebase and the new ref. So, and we don't need to do anything here. Also, yeah, the commit version where we are, and the GPG key which we signed. And now let's see the Python. So I will do RPM-QA Python. Sorry. Yeah, there is no Python. Okay. See, no Python 3. Yeah, okay, I think that's pretty much for demo. It's running, and now if you want to run something, you have Podman or Docker available. So you can do all the container things from here. Okay, and I think Jakub will show the demo for PowerPC.
So as the CoreOS assembler was mentioned, for CoreOS it's extremely easy, even if you are not on some more exotic architecture like 64-bit ARM or PowerPC. It's extremely easy to hack on building the OS itself compared to for regular Fedora. So really go there and check out the CoreOS assembler if you want to try to build your own Fedora CoreOS. And based on that, you basically get the assembler, you build the assembler container, and then you run the assembly in the container. There are a few stages. You fetch all the configuration information that goes into the build, you fetch the packages, and then you build the artifacts. That's what bits that I did here. And I can show you that you currently, with the master branch of both of the config and CoreOS assembler, you can actually run it on power. If we have networking. Yeah, so yeah, presentation goals are not here, but basically you can run it even on your. You can build and run the images if you for whatever reason want to build it and hack it on. It's really easy and really check it out. It's really cool, and yeah, and there is built functionality to the assembler container that you can run the resulting images, which I would show here, but unfortunately the network is not here. So yeah, so back to Sinny.
Okay, that's bad. Internet is really flaky. Yeah, so maybe if you have a PowerPC system, you can go and try it yourself.
Yeah, on 64, and I'd be really happy to hear about it, how it went, or we can try it together. Yeah, and the community around Fedora CoreOS is great. So if you stop by on RC or other channels, they will help you with any crazy stuff you are doing.
Yeah. So the future plans. So what the upcoming things in Fedora CoreOS. So we have a lot of things already in place, but few things we really want to get done, which is like, yeah, the next obvious step is the next and the stable stream. So right now we have only testing, and it's also intentional because it's a preview release, right? So we want people to test, and we want to give them feedback, file issues or anything. And we don't want them to run in production, so that's why we don't have stable for now. So we'll like to get the next and stable stream soon. Also, we have ISO and PXE booting running, but we want the live ISO PXE as well, so that people don't have to really install. They can just try out and see how it goes, and then they can install it whenever they want. Also, support for other cloud providers. There will be a lot of cloud providers, and right now we are on AWS. So we'd like to go to other Azure, DigitalOcean, or anybody else, whoever is interested to want to add Fedora CoreOS on their cloud. So integration with the Kubernetes distribution and OKD, things are already in progress for OKD. There are lots of discussion going on. So if you want to really get involved and get more information, you can follow the OKD mailing list or the IRC channel and see where we are for Fedora CoreOS on OKD. Also support for architectures, different architectures are already going on. Everyone is so friendly, and people are doing the changes and sending patches. So more input here would be really welcome. Also the toolbox. So there was a talk about toolbox in another room, I think few hours back, and that's really nice. I have Fedora Silverblue system, and I every time use toolbox for anything because it's a RPM OS3 based immutable host. So you really need DNA for anything to do. So you need toolbox. So similarly, if you want to do some debugging or anything, toolbox is really handy. So we'd like to get the toolbox in place in Fedora CoreOS as well. But yeah, I think there is some work needs to be done to get it on Fedora CoreOS. We want to, I think, remove some dependencies, which is part of toolbox so far, and maybe there are a few additional details. Also documentation, it's very important. Right now we have this new Fedora CoreOS, which is like the lots of hell new things we don't know. Even I don't know lots of things still. So lots of documentation. Yeah, we have few documentation, but more documentation for each tooling and how you want to use, what all ways we can do, what things can be done. It will be really nice to improve documentation there. Anyone can contribute to the documentation if you're doing something and want to add. It's really everything on GitHub. Also, preview release, we want to continue it for a few months, and then we'd like to get a stable release coming soon so that people can run in the production. Yeah, and yeah, that's the summary of the whole talk. It's like the Fedora CoreOS itself is a minimal OS with focus for the containers. Also, it provides you immutable infrastructure, which we talked like we don't want anything to change on the operating system itself. If you want something to add any config, then you change your FCC config and you provision a new host there, and that's how you keep your system without any manual changes there. Also, we have multiple streams available in Fedora CoreOS, which helps to run things smoothly, test coming features in advance, catch any regression. So that really helps Fedora CoreOS to be a stable operating system focused for containers. Yeah, that's all. And if you want to get involved, these are few things. I'd recommend first try Fedora CoreOS preview from the link getfedora.org, and if you encounter any issue, file it on the GitHub Fedora CoreOS tracker. Also, we have some documentation in place to get started, how you can try out those images. So you can get that, and yeah, we have IRC channel has #Fedora-CoreOS, or to join mailing list for more updates. That's all. Thank you. And there is an interesting talk from Luca tomorrow at 11 about auto updates design. So he will dive into that, and that if you are interested in that.
Yeah, thank you too, and let us know how the Fedora CoreOS went for you.
Yeah.
Went for you on your platform of preference, whether it's Intel or whatever.
Yeah, through IRC channel or discussion or through mailing list or file issue tracker. If you don't say something there, we'll really try to get it in from your support. Any question? Okay. Who goes first? Maybe Matthew. Yeah. As far as I know, there is going to be a separate side release for OKD, at least initially, so that people can try it. It can be maybe the first kind of preview release how we have for Fedora CoreOS. So there is a different working group set up for OKD on Fedora CoreOS, and once it's like it goes a bit stable, maybe in future we can have something together in place. I can't talk about that much future, but that's how it's currently it is. Yeah, definitely. Yeah.
What did you mean by kind of integration with Kubernetes distributions? It didn't mean what you described.
Yeah, Luca, you can take.
So the problem that we had we want to run everything as a container, including. Sorry. So we want to run everything as a container, including the cluster management and stuff itself. But the problem is that the agent that Kubernetes uses, which is called a kubelet, is not something that can be containerized easily. And from that on, there are a bunch of other requirements that stems from the kubelet. For example, like some specific version of kubelet can be used on some specific version of Kubernetes and only with some specific version of Docker or CRI or whatever, which means that as soon as you fix the version of Kubernetes that you're running, you cannot update the rest of the system independently. And so we have this kind of struggle with, we want to provide a minimal OS, which auto-updates to the latest version, the stable, the securest, whatever. But at the same time, if we do that, we are also mandating which version of Kubernetes you are running, which we don't want to do because it's an application, it should be containerized. So there is a bit of like friction that we need to solve in that regard. And OpenShift doesn't have this friction because the kubelet, which is the OpenShift kubelet, and CRI, they are part of the operating system, and the operating system version is part of the OpenShift product. So it's everything comes as a single stuff.
Thanks.
Peter? For automation, you mean the host automation or something?
Yes. Like if I wanted to like do conflict management with Ansible across thousands of endpoints, how would you do that?
I think Luca will be better too for this.
Okay, I can take that one as well. You will not like the answer. I can provide 3 different answers. The first one is like you don't, because it's an immutable infrastructure. So if you're changing something in the OS, you redeploy it. That's the first answer. The second answer is, in fact, there were people running Ansible on container Linux in 2 ways. The first one is like trying to containerize Ansible itself and then bind mount stuff into the container if you're just like touching files. And the other one is like run Ansible, but without depending on libraries that are part of the OS, which is in general a better answer, because if we update, let's say that you depend on some OpenSSL version, and we update OpenSSL for you, then we break Ansible that you are providing because you depend on a different version of OpenSSL. So as soon as you manage to split your application from the OS, you can do whatever you want. Our preferred answer is like you don't, and you just redeploy the node, because anyway the node could go down and be redeployed at any point because AWS decided to kill your node, for example.
Thanks again.
Sorry, I'm taking a lot of answers, sorry, but it's like, most of this is what we were doing with container Linux, and we just ported it to Fedora CoreOS, so I can give like a bit of historical perspective. And like, from our point of view, the server is dumb, it's just providing the ignition configuration, and it could be just like whatever HTTP server you want. And then the client is applying that on first boot only, which means that you are redeploying the switch from our point of view, which could take like a lot of time if your infrastructure is large, but it's not putting stress on the server itself. It's putting stress on specific portion of your network. And the other kind of like approach that we have is that we build our tools so that you can define maintenance window per cluster. And so you can say, for example, when there is an out update, you can say, I want exactly these 4 nodes to be in the same group for out update and only be rebooting 2 of them at a time because I want to have some kind of like HA continuously. And if something goes wrong, we stop the rollout of out updates. So this kind of like approach to you define how you want to manage your updates and stuff. But from the point of view of the infrastructure, like the nodes themselves, they are really cattles. They could disappear at any point, and they could be just be redeployed from scratch.
Any more questions? So the package name is Moby-engine. It's not Docker. Docker is a different package. Moby-engine, yeah.
Okay. Question for you. Do you know if there is like a PowerPC cloud or like some cloud provider providing PowerPC machine?
I believe there are some. I believe even like VMs and bare metal hosts, but I have not looked at the direction yet fully. And some smaller ones. Like I stumbled on one or two, but I cannot remember from top of my head. And I believe, of course, IBM.
Yeah, so you can see like I'm in the system, and if I do which Docker, it's a Moby-engine package. Any more question? Okay, thank you guys. Do try Fedora CoreOS and let us know how it goes for you.